So most of the questions on the quiz are about those interrelationships between F, F prime, F double prime. If you have a good handle on those, you can do really, really well. If you're off on your understanding of those, you can miss a whole bunch of questions. Now, don't be scared of that, other than the fact, make sure you really ask questions, make sure you understand these interrelationships, and just make sure you're careful. Make sure you read the problem carefully, right? Make sure you do the right assignment, right? You know, so the question says, so when the question says this is the F graph, make sure, you know, okay, now this is the F graph. They're asking me about F prime, okay, so I got to make sure that you're doing that. As long as you don't try to rush through it, just, oh yeah, boom, 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 right? Because we spent a lot of time talking yesterday about if this was the F prime graph, what are we looking at? But this is the F graph. So where is F prime negative? When this graph is what? Decreasing, right? So, and again, let me emphasize this. When it says when is it happening or where is it, we're talking about the x values, right? And so all I want you to have there is an interval. I want you to have -5 to -2. I don't want you to include those endpoints. Any chart stuff, we are not including the endpoints. Okay, so if we look at the chart, I've got a new version of the chart. Now, the only part of this that we've actually talked about so far is this part, right? So let's just focus on this part right now, okay, where this is F and this is F prime, okay? But they ask when F prime is negative would be when F is decreasing. That's the part we're looking at. Yes, sir?
If you use negative infinity for your point, would that be wrong?
Okay, that's a great question. What my rule of thumb is going to be, and I'll probably say this to you when I give you the quiz, if you get a boxed in grid like this, let's just end it there and there. Okay, for now it wouldn't be because you didn't know. If I give you just an axis and then there's arrows at the end, then we would use infinity. Okay, then we would use infinity. So this one I would say -5 to -2. Okay, anywhere else? Yeah, is it really at 2? Yeah, it's close enough, so 2 to 5. Okay, and you just do that. Okay, and there you go. Now it says justify your answer, so you really should say that's where F is, what did we say? Decreasing. So where is F prime negative? Here, because that's when F is decreasing. Okay, all right, and then where is F prime decreasing? What did the chart say about F prime decreasing? That's when F is decreasing when F is concave down. F prime is decreasing when F is concave down. So F is concave down where? Well, did it tell us where the inflection point was? Didn't. I'm just going to assume that's at 0. Looks pretty close. So it's concave down from 0 to 5, right? F prime is decreasing from 0 to 5, okay? And then it was just the reverse of that for 22, okay? Where does F prime have its max value? What'd you say? At x equals 0, right? And it is the inflection point, but you'd want to say at x equals 0, right? F prime is a slope, right? Its max value means its highest value. Well, these negatives are not going to be the highest value, right? Negatives are smaller than positives. So its highest value has to come in here. These are the slopes, right, that are positive. Well, the biggest positive is where this is the steepest, which is right there, the inflection point. So that is where it is. Now, it says estimate F prime at this value. So what are you going to do? Rise over run. What do you get? 1.5? Look reasonable? You're going to have to do that on the quiz. You're going to have to understand that what I want at this point, this is the F graph. If I want F prime, one of the ways we had to get F prime was pick 2 really close points. But you can't do that here. You have no equation to plug them into. You can't do 0 and 0.0001, right? You have nothing to plug into. So the other way we had to estimate slope was rise over run. So I want to see your line. I want to see your little triangle. I want to see how you're getting that. I'd say about 1.5. Pretty good.
So what are the
What do these mean? What do they mean for F prime? Well, this is F, so F prime would be the slope at these points.
So is that just like a flat point? Because it stays negative, like it doesn't change from increasing to decreasing, or decreasing to increasing?
No, it does. I mean, it's decreasing, then it's increasing, right? So we got to think backwards of what we were doing the other. What are the slopes right here? The slopes right here are, no. No, the slopes, see this is the part I said gets interesting. Okay, and you guys are throwing a lot out here. Jesse, now think about what you just said. I said the slopes right here are what? You said decreasing. No, the Y values here are decreasing. What are the slopes doing right here?
Getting smaller.
No, what are the slopes doing right here? They're getting bigger. Think about that a minute now. The slopes right here are increasing. Aren't they? What's the slope? Give me a slope right here. Give me a slope right here. -4. What's the slope right here? -3. What's the slope right here? -2. What's the slope right here? -1. What are those numbers doing? Oh, okay. I thought you said decreasing. They're getting bigger. The slopes are getting bigger when you go here, right? Because on the chart, what happens when F prime, the slopes are increasing. F is concave up. This graph is concave up all the way to here. So the slopes are increasing this whole way. So you guys are confusing this graph going down with what its slopes are doing, right? Those are two different things. This graph is going down when its Y values are going down, right? This is the F graph. Those aren't slopes. So these Y values are decreasing, right? Not the slopes, okay? But I got off track with what you were saying. So what does this point have to do? The local minimum here has a slope of 0. When F has a local minimum, F prime is 0 there, right? The slopes are negative, and then they're turning to positive. Now I think Max, you said it, on the F prime graph, that would be a root, right? This, if we were going to draw an F prime graph, right, these are negative slopes, so they'd be below the x-axis. They'd be coming up, because they're increasing, right? They'd be coming up to the x-axis. It'd be 0 right there, and then they would become positive, so it would go through the x-axis, right? It'd be a root. Just like yesterday I told you, if you have an F prime graph, it would be doing that. It would be going negative to positive, right? When we were doing that matching, if you have an F prime graph, and it goes negative to positive, what's the F graph doing? Down, then up, which is what this one's doing.
So whatever your like minimum and maximum are on your F graph, that's going to be where it crosses the x-axis.
Where F prime crosses the x-axis, right? Yes, absolutely. We talked about that. That's the first derivative test. This is going to be a local min, and that's going to be a local max right there. Remember wasn't that the first derivative test yesterday? When F prime changes from negative to positive, F changes from decreasing to increasing. That's a local minimum. When F prime changes from positive to negative, F changes from increasing to decreasing. We got a local maximum. So I think you guys understand it, but you got to be careful what you say, right? You got to be careful what you say, because you're going to be writing out your explanations on these things. You've got to say the right thing. If you write in your explanation because F prime is increasing, and what you meant to say because F prime is positive, that's wrong. See, those are two different things. F prime positive is not the same thing as F prime increasing. Okay, those are two different words. All right, and then 24, you're supposed to sketch a graph of F prime. So, well, let's just do that. So F prime now, what we're doing, remember, the Y values of F prime are the slopes on this graph, right? So I would do, if I was doing this, I would do just what I did a minute ago. What's my slope here? Give me a slope. Let's say -4, -3, -2, -1. So over here, well, I'm going to do it right on top of this graph, it'll be easier. So right here, I got a -4, let's call it -3 or whatever. It's down here, but then it's coming up, right? And it's coming up, and it might be curved, or we'll go ahead and curve it. And right here, it's got a cross, right? So this graph's got to be coming up, and it's got a cross right there. That's what we just said. When this graph's going down, this one's got to be negative. It's got to be down here. Then it's going up for a while. So this graph's got to be positive for a while. Now what happens at that inflection point? That's where it's going to have a max, right? That's where the graphs are positive and getting more positive now, but now they're positive and getting less positive. So now it's got to come back down. It's got to cross right there, right? This has to go from positive to negative now. Okay, so at our minimum, we went negative to positive. Now we're going positive to negative, and now they're going to be negative. Now the slopes are negative and getting more negative. So it's just going to go down. It's just going to be a parabola. Okay? So just like when we were matching yesterday, this F prime is negative then positive. Okay, we're still not very good at that because a lot of you did not have this on your paper for number 24. Okay? All right, let's go to the next group. This is one of those sections I don't mind going through the homework pretty, I mean, it's just such a fundamental concept. We've got to have this. Now, we switch gears, right? Now we got G prime as our graph, right? And that's more common than we have we do the derivative graph and then we ask questions about the original. But you got to be able to go both ways. Okay, where's G increasing? Well, that's when G prime is positive. Now, can it also include when it hits here? So what would you say? From 0 to 5.5? I would agree. I would say we would not eliminate that. Now, it didn't. What if it would have said, where is G prime positive? Where? Okay, now you'd think those two things go together, right? G's increasing when G prime's positive. Well, for G increasing, I said all the way to there. Okay, that's correct. But what if the question would have been, where is G prime positive? Could you include this point? G prime is not positive there. It's 0. Right? 0 is not positive. So you'd have had to say 0 to 1 and then 1 to 5.5. Right? So just a little bit of a technicality there. But where is G increasing? It's D. That's just, what is that on G? That's a flat spot, right? Because remember, this is G prime graph. So this is just like when we were doing the matching yesterday. It's positive, then it stays positive, it's still positive, switches to negative, it's still negative, switches to positive. Right? So we're looking for a graph that goes up, keeps going up, now goes down, then goes up. So we're going to have a graph that goes up, and it's going to flatten right there. This is going to be a local max right here. This is going to be a local min right here, right? Just what we were talking about. Here, F prime is changing from positive to negative, so F is changing from up to down. Here, F is changing from down to up. You're going to have a min. Okay, and so Emily goes back to what you were saying earlier, right? A max and min on the F graph is going to correspond to those roots where it crosses. I like the word crosses there because if it doesn't cross, if it bounces off, that's where you got a flat spot, right? If it doesn't cross through, you don't have a sign change, positive to negative. Okay, but anyway, we'll get to that. So it's positive from there to there and then from 9 to 10. Right? There's going to be a lot of problems on our next quiz like this where your answers are these intervals like this. Okay? And then also, it doesn't hurt to give your reasoning too. Decreasing would be the other ones. Where does G have stationary points? Missing one. And 1. What are stationary points? When G prime is 0. So there, and there. Even though it doesn't cross, right, it's still a stationary point. It's where it's 0. So it's where it hits the x-axis is a stationary point. And write it like this. Write it like this. Don't give me points. Don't do this. Don't say a 1, 0. I don't want that. Okay, because that's a point on the G prime graph. The question is, where does G have stationary points? That's not a point on G. The G graph's not going to be a 1, 0. It might be, but it'd be a coincidence, right? Don't give me that point. Don't give me 1, 0, 5.50, and 9, 0. I don't want that, right? That's not what it's saying. And it'd be wrong because we don't know that that's a point on the G graph. What we do know is there'll be a stationary point at those X values. We don't know what the Y value will be, right? It could be anywhere. I don't care about that. I want that. Okay, that's how you give that answer. Where does G have local max points? Well, I just said it right there, x equals 5.5, local min point right there. Is G concave up at 3, okay? Well, you go back to the chart, how do we tell if G's concave up?
It's increasing.
If concave up, if G is increasing, right? G prime, excuse me. So G is concave up when G prime is increasing, okay? So, right here at 3, is it increasing? Yes, so it is, and that's your explanation. And then is it concave up at 6? No, because G prime is decreasing. So G would be concave down or concave up, okay? And then they tell you that these max points, that's at 3.8. It tells you that this is at 7.4. What do these say about F? What's happening on the, or not F, G. What's happening on the G graph right here and here? Inflection points, right? Those are inflection points because this G prime is changing from increasing to decreasing. So we went through just about every chart thing in this problem. G prime is changing from increasing to decreasing at that max. So this is that switching columns thing we talked about. So therefore, G is changing concavity, okay? So you've got inflection points at those 2 points. Now you also have one back here too, but they didn't mention that there would be an inflection. That's a flat spot, but it's going to be an inflection point too.
So how concave up, we need to go down and then up, right?
No,
Like,
here's e to the x, right?
that would still be concave.
That's concave up all the time,
Okay.
all the time. So it's a horizontal asymptote. It's going to just go down, 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 and down, but it's concave up all the time. So it does not have to go down and up. No. Good point, though. That's okay. Just the curvature of it. Suppose that G of 0 equals 0. Sketch a graph of G. So I'm just going to put it right on top of here. But notice, remember we said yesterday, if you have the G prime graph, we don't know where to start the G graph? But now we do, right? What they've done is given us an initial condition. They've said, okay, start your G graph here, and then now you'll know where to go with it. So let's do it. Well, so what do we know? The G graph's got to go where? Up, flat spot, up, flexion point, keep going up to a max, right? So we with all that information there, right? The graph and the G graph's pretty easy now. So it's going to go up, but now what's its concavity going to be? Doesn't have to be concave down because this graph is going down, right? If G prime is decreasing, G's got to be concave down. So this is going to be concave down, flatten, then it keeps going up. So now it switches to concave up all the way to there. Oh my God, I'm going to run out of room. It's not going to let me draw past there, so let me not go up quite so high. Flexion point, now it switches to concave down till I got a local max right there. I just didn't want to go up as steep, so concave down, then it's concave up, and then inflection point, and now concave down because this is decreasing, but still increasing that whole time. Got local max, now it's decreasing till where? About there. And then I got an inflection point, so it's still decreasing till I get to a minimum. And then it's going to come back up, something like that. I don't know exactly where it's going to cross or hit, or whatever. But yeah, that's kind of messy. But you get the idea. Okay. Would this have to cross? No, that's what I'm saying. I don't know. And that's a problem. We're gonna talk as we go through the year how we can make that better and know exactly where that is, because it has to do with this. I mean, how far down does this go? The farther down this goes, that tells you your slopes are steeper, right? So like right in here, at my inflection point, I had to have a slope that's almost -2.5. So did I draw that? Does that have a slope of -2.5? I may not have drawn it steep enough, right? It maybe should have went down farther, you know? So I didn't get that picky. I just want the general shape. But you're right. If I really was going to draw a good G graph, I should be looking at these Y values and seeing what the slope is and trying to match that. I really, really wanted an accurate one. But I'm not gonna get that picky about it, okay? Because yeah, these Y values do tell us how steep this graph is, right? So I could really get picky and try to do a good one there. All right, so, oh wait, then I skipped the tangent line one. See, gosh, this drives me nuts. Well, how can I teach this? I don't know. This is one of my great failures in teaching calculus, that I can't get people to be able to write the equation with tangent line. Okay, that's how you write the equation of a line, right? You need a point and a slope. Wow, if only in calculus we knew something about slope. Oh wait, the derivative. The derivative is slope, right? So at the point 3, 4, g of 3 equals 4. So what they just give me there? Point. And so, you know what? I'm going to quit using m. The heck with m. Well, I'll still write out m there. But I'm not going to write m anymore. I want that, right? That's what I want. G prime of 3, right? Because that's the slope at 3. What's g prime of 3? Isn't this the g prime graph? At 3, it's 2. So what do I got? Y equals 2, x minus 3, plus 4. That's it. Isn't that easy? What, right? I mean, Patricia and I were talking about earlier. I mean, what's hard is recognizing where to get the slope, right? Where to get the slope. I mean, it's the derivative. It's the y value on the g prime graph is the slope of g at 3, right? So if I want the equation of the tangent line, because here's my tangent line, because I drew my g graph. My red is my g graph right there. So that would be the tangent line. I want the equation of that line. Okay, well, it's got a slope of 2, because I know that's what that tells me. And I just, obviously my graph's wrong, because it's not at the point 3,4, is it? It's supposed to be at the point 3,4. It's at 3 something else. Okay, but anyway, that's the equation of that line. Okay, so what about 35? They give you a different point, 9, negative 1. So, and what's the slope at 9? Oh, that was a minimum, right? Well, that should be just y equals negative 1. Should just be a horizontal line, right? Horizontal line, y equals negative 1 is a slope of 0 there. Okay? I don't even care if you simplify that. You want to leave it like that, I'm okay with that. Okay? That's it. Equation tangent line. Could g be the function x times sine x? Now, to answer that question, I didn't just graph it on your calculator, right? Graph x times sine x. Now, remember, if you graph x times sine x, kind of like that one we had on the last quiz, you got to put a dot in there. You got to put a time sign in there, and it's not going to graph for you. Okay? I think the answer is no. If you graph x sine x, it doesn't look anything like that. So that's all that was about. Okay, where did we go to next on the homework? 46 and 51. Okay, so in 46, this was what? The F graph? F graph. Okay, so how many roots does F prime have? There's just a bunch of different questions we can ask. You know, just mix it around, give you an F graph, give you an F prime graph, ask you about F, ask you about F prime. We're going to get into F double prime today. And just don't get confused. It all comes back to this. Root of F prime. Root means where does F prime equal 0, right? Well, where is that? That's at, right? That's when the slope is 0. Oops. Well, where's that at? Or the question was, how many roots does it have? Just one, right here. Right here, the slope is 0. And that's at x equals, it says where are they located? X equals 0. Okay? Where is F prime positive? Negative infinity to 0. Right? Negative infinity. Oh, God. Jeez. Negative infinity to 0. Because that's where F is increasing. F is increasing when F prime is positive. Is F prime increasing at 2? That'd be over here somewhere. No. decreasing.
Getting more negative.
No, well, because what does F prime increasing mean?
The slope is getting more positive.
Well, yeah, I don't mind you thinking through it, that's fine, okay. Is F prime increasing? Well, there's two ways numbers can increase. They can go 2, 3, 4, or they can go negative 2, negative 1, 0, that kind of thing. That's increasing. So these slopes are getting what? Negative 3, negative 4, negative 5, negative 6. What is that? That's smaller, that's decreasing. Now, if you want to think it through that way, you can, but I think that's making it harder. I think if the book asked me, is F prime increasing? If it says is F prime increasing, I would come to my chart, I would look at the F prime line, I'd see when F prime is increasing, F is concave up. And so I would look at this graph and say, is F prime increasing? That's like asking me, is F concave up? No, F is not concave up, it's concave down. It's concave down the whole time. So the answer would be no. Sketch a graph of F prime. Well, we did that already. This one, okay, so what do you got? What's the slope right here? What's the slope right here? No, just give me a number for slope right here. 3. I think it's more than that. Let's go 5. What about here? 4, 3, 2, 1. So I need to graph 4, then 3, then 2, then 1, then 0, then negative 1, then negative 2, then negative 3, then negative 4. Right? It's a line. It's going to be a line. That's what it's going to be. The diameter curve. Right? It's got to go from positive to negative. Why does F prime have to go positive to negative? Because F is increasing and decreasing. Right? Just like on that match. Okay? That's F prime. All right, 51. This is F prime. Okay? So you graph F prime. Where is F increasing? And what was this point right here? This is negative 4, I think. And this is 2. Sure it is from here right here. Okay? Now, to be honest, this could most definitely turn up on a no calculator. The expectation is that you would know that this is a parabola, because if you FOIL this, this is going to be an x squared. And they've written it in this nice form because that tells you your roots are 2 and negative 4. Right? That's simple algebra. You FOIL it, you solve it. These are if you set this equal to 0, if you want to know where this crosses, it's going to cross when this one is 0 or this one is 0. So my expectation, I'm not saying I'm going to do that on this quiz, but it certainly could be there. That you know this is a parabola, it faces up, and it's going to cross at negative 4 and 2. There's no reason we can't graph this without a calculator. Okay. Same with the other one. To be honest with you, 3 minus x squared. It's upside down, shifted up 3. So this one was upside down, shifted up 3, right? So you had your calculators, that's fine, but there's no reason we couldn't have done this without a calculator, done these problems without a calculator. So just keep that in mind. Where's F increasing? When this graph is what? Positive. It should be here and here, right? So from negative infinity to negative 4, and from 2 to infinity is where F prime would be positive, or where F is increasing. At what values of X does F have stationary points? Right here and here, when F prime is 0, which is those 2 places. Where does F have local minimum? Right here, at 2, because F prime goes from negative to positive, so F would be decreasing, then increasing. This is a minimum. This is going to be a maximum. Okay? Where is F concave down? F is concave down when F prime is decreasing, which would be negative infinity to, that's negative 1, because this is a distance of 6, so it would be 3 away. It's symmetry, so it would be at negative 1. That would be at negative 1. Again, we should know that without a calculator as well. It's at negative 1. Okay? So from negative infinity to negative 1. Concave down when that's decreasing. Sketch a graph of F. Okay, boy, we've done a bunch of these. Sketch your f of f. So this is f prime, right? Positive, negative, positive. So the f graph's got to do what? Up, down, up, right? Now who knows where it starts? I have no idea. So it's got to go up. It's going to have a max there. It's got to go down. It's going to have what right here? Inflection point. So it's going to have an inflection point. Then it's going to switch concavity to have a min. And then it's going to go up, right? I have no idea, shifted wise, up and down, who knows where that is, but it's going to go up, down, up, because the f prime graph is positive, negative, positive. And you're going to have an inflection point right there, okay, because of concavity switch. All right, that's a lot of, I mean, that's a lot of good problems. I mean, that could be half the quiz right there, more than that. Those kinds of problems. F prime, chart, right? You memorize the chart, you got that close by where you can do something with it, you got it. Okay? So let's take our chart and let's add to it today. Okay? So, I've got it right here. And we're going to add a row called f double prime. Now, here's the first thing I want to tell you. What's the relationship between f prime and f double prime? Well said. The slopes of f double prime, excuse me. Well said. Yeah, I screwed it up. The y values of f double prime are the slopes of f prime. What's the relationship between f and f prime? Because that sounds familiar, what you just said.
Y values of f are the slopes.
The y values of what? The y values of f prime. Is that what you said? The y values of f prime are the slopes of f, right? I guess my point is this. Isn't the f prime, f double prime relationship the same as the f prime relationship? Isn't the f prime, f double prime relationship the same as the f prime relationship? There's nothing new to learn there, right? There's nothing new to learn there. Think of today's homework. If you took today's homework and everywhere there was f, you changed it to f prime. And everywhere there was f prime, you changed it to f double prime. Wouldn't it have been the same homework? What happens when f double prime is positive? F prime is increasing, right? Because f double prime is the slopes of f prime. So when f double prime is positive, f prime is increasing. And when f double prime is negative, f prime is decreasing. See, but I already had that in my chart. I already had increasing and decreasing on f prime, so I end up putting it in a little different order. Remember, yesterday, this is all we had, right? We already had this in our chart right there. But now I introduce f double prime. Well, that's just the slopes of f prime. So if f prime is increasing, that means f double prime has to be positive, right? Because it's the slopes. And when this is decreasing, that has to be negative. But then I want to add some more stuff. So I got that from yesterday, but then f double prime could also be 0. Well, if that's the slopes of f prime, that's when f prime is a stationary point, local max, local min, or flat spot. Okay? And then, of course, f double prime could be a couple other things. If we look at my f prime row, f double prime could be increasing. That means f prime would be concave up, and f double prime could be decreasing. That means f's concave down. So, right, I mean, because that, I want those same 5. I have these same 5 relationships here for f prime and f. I want those same 5 for f prime and f double prime, right? So the red part of this So the red part of this is nothing more than the same thing we had in the blue part, right? Everybody agree with that? So F prime, F double prime, the red part is just these same relationships that we had in the blue part between F and F prime. Okay? Now, I'm going to get all kinds of colors going here. So we notice that local max and mins on F don't really have anything to do with F double prime down here. Or, I mean, you know, so these are just kind of blank. But we do get a couple of new relationships here. And let me put that in, I guess, this green. We do get, oh, oops. We get this right here. That's what I want to focus on today. The green box. Or boxes. Right? Because the red box is nothing more than what we already learned. So if you get a problem that's talking about F prime and F double prime, well, that's the same thing you've got with F and F prime. Right? So I can give you that card matching activity on Desmos and tell you that the red graphs are F prime and the blue graphs are F double prime, and you do it exactly the same way. Right? You do it exactly the same way. All right. So we are actually going to do an activity where we're going to just look at some F and some F double prime. Some F and some F double prime. Well, that's the green boxes. So what does F double prime tell me about F? Okay, now, so here's the lesson, I think, is F double prime, if we're talking about F now, F double prime really just tells us concavity. Okay, if there's one thing I want you to take away from today is that F double prime is about concavity of F. F double prime is about concavity of F. That is the main emphasis of today. F double prime is the concavity of F. There's nothing new in the F double prime, F prime relationship. There's nothing new there. F double prime is just the slope of F prime. And F triple prime would be the slope of F double prime. Right? And F fourth prime would be the slope of F triple prime. You know what I mean? There's nothing new there. The new thing is that F double prime tells us about the concavity of F. If F double prime is positive, F's concave up. Now, we can go through the middleman to understand that. When F double prime is positive, means F prime's increasing, but we learned yesterday when F prime's increasing, F's concave up, right? I mean, that's why we get that. But what I'm telling you is we can just remember that when F double prime's positive, F's concave up. And when F double prime's negative, F's concave down. Now, Will, you said this a long time ago. You said when there was if F prime had a local max or min, that F had an inflection point, right? Well, if F prime has a local max or min, isn't F double prime 0? Right? But notice I put possible inflection point. Because if F double prime is 0, does that mean F prime had to have a local max or min? F double prime might have had a... No, well, a stationary point is when F, right? A stationary point is when this is 0, right? And these are the three things it could be, right?
Wait,
You're
so
thinking flat
is the
spot.
stationary point where it, oh, yeah, I was thinking flat spot.
Stationary point are, these three are all stationary points. Those are stationary points. When the slope is 0.
Is a stationary point the same as a flat spot?
No. Stationary point is anytime the slope is 0. Stationary point is when the slope is 0. So right here, the slope is 0. Right here, the slope is 0. Right here, the slope is 0. Stationary point could be a local max, a local min, or a flat spot. Okay.
So a flat spot is.
A flat spot's a stationary point. A stationary point's not necessarily a flat spot. Because it could be a local max or a local min. Okay, stationary point is when the derivative is 0. That's what it is. Okay, so back to this. So just because F double prime is 0 doesn't mean F prime is a local max or min, right? It could be, but it might not be, right? So it's a possible inflection point if F double prime is 0. Well, let's talk about this. Quick way to do this, we just had this graph right back here. let's go right back to this graph right here. Let's pretend for a moment that this graph was G double prime. Okay, you with me? Let's pretend that this is G double prime. Now, it's positive, then positive. Okay? Now remember, what did G double prime tell me about G? Concavity. So when G double prime's positive, what's G? Concave up. Right here, G double prime is 0. Then it's positive again. So this went from concave up to concave up. Was there a change of concavity? Is there an inflection point? There's no inflection point unless you have a change of concavity, right? Well, so what we're saying is, remember when this was G prime and it bounced off, we said we had a flat spot? Well, if this was G double prime and it bounces off, no inflection point, right? G double prime is 0, but it's not an inflection point. It has to cross. Emily said that earlier about crossing, right? Because what happens right here? G double prime is positive, then negative. So what's that mean? If G double prime is positive, then negative, you switch columns, right? So remember yesterday when we wrote our chart, we did this. We said if you switch these two columns, that was local max min, right? What happened when you switch these two columns? Inflection point. So just because F double prime is 0 does not mean you switched columns, right? Just because F double prime is 0 does not mean you went from positive to negative or negative to positive. It just means it's 0. It might have been positive, bounced off, and stayed positive. Make sense? So that's why if F double prime is 0, that's a great place to look for an inflection point. If F double prime is 0, it's a great place to look for an inflection point because that's where this is going to switch, but it might not have switched, right? So it's a great place to look for an inflection point, but it's only an inflection point if it switched columns and changed concavity. Okay, so that's the key to that. All right, and then you get this other thing here. I always put this over here, but it doesn't really tell us anything about F. So this part over here isn't that big a deal. So the new thing we learned really is this relationship right here. Is that F double prime is positive or negative or 0, then if it's positive or negative, we got concave up or concave down, and of course if it's 0, that's possibly a inflection point, but it has to change concavity. So that's really only the new thing we learned when we added F double prime. Because the other stuff, we already know. F double prime to F is just, F double prime to F prime is the same relationship we had before. All right. So I got one last time. Okay. So we got a couple of different activities here to talk about, but I do want to turn to page 65 if you would. 65, 66 actually. On page 65, there's a comment. On page 65 they make a comment about if a graph is concave down, then the tangent line is going to be above it, and if a graph is concave up, the tangent line would be below it. Just kind of common sense because of the curvature of it. So concave down, tangent line's above, concave up, tangent line's below. So they make that note. There's something called the second derivative test. And I just want to make a comment about that, and then we're going to do a couple of your homework problems here together, actually, as it relates to that. The second derivative test. Now remember, the first derivative test was testing to see if we had a max or a min. Okay? Well, we can use the second derivative to test if we have a max or min also. And here's what it says. If x equals a is a stationary point. Now notice I didn't say critical point, which I did for the first derivative test. This is just for a stationary point of f. Now remember what that means. That means f prime of a equals 0 is what that's saying. Okay, it means the slope is 0. So that means we either have this, this, like Emily, we were just talking about, we either have a local max, local min, or a flat spot, right? So a stationary point, we have one of those three things. So if x equals a is a stationary point of f, then if f double prime of a is positive, what's that tell you? Concave up. Well, which one of these three situations is that point concave up? Local min. So if f double prime of a is positive, then it is a local min. If f double prime of a is negative, it is a local max, because it would be concave down. See, you already know it's a stationary point. Remember, that's the key. You have to know it's a stationary point, right? First. And then what we're trying to do is test to see if it's a local max min. So the advantage here is we don't have to look on both sides. We don't have to say, okay, f prime changed from positive to negative, or f prime changed from negative to positive. We can just say, hey, plug it into the second derivative. Now, you might not have the second derivative, so a lot of times we don't use this. The first derivative test we use way more. A lot of times you don't have the second derivative, you just have the first derivative, right? So we don't use this, but it can work. Now, if f double prime of a is also 0, it could be anything. We don't know. It could be a flat spot, it might be a local max or min. It could be whatever. We don't know. We don't know. So if you have a stationary point, if the first derivative is 0 and the second derivative is 0, who knows, right? So you probably do the first derivative test, okay? But it makes sense because a local max is concave down, a local min is concave up, and a flat spot isn't either one of those, right? So anyway, so let's go to your homework. We got a couple things. There's a Desmos thing, and then there's some book homework. Yes.
Did you use the first derivative test on like f double prime, f prime?
Yeah, same thing. So if it was asking if f prime was a max or min, if it was asking if f prime was a local max or min, you could look at f double prime and see if it changed from positive to negative. That would be considered the first derivative test because f double prime is the first derivative of f prime. Make sense? F double prime is the first derivative of f prime. Okay. All right. So let's go to your homework here. And the first part of the homework is, there's some back in 1.6 you're supposed to do, but 4 through 8. So on 1.7, 4 through 8. So let's just talk our way through those a little bit here. We'll at least do a few of them anyway. Okay? So 4 says, suppose that the function j prime has a local max at 2. So j prime has a local max at 2. Right? You with me? This is on page 68. So j prime has a local max at 2. What does this imply about j double prime? Doesn't it have to equal 0? Now, we could get pickier. Couldn't it do this? Couldn't it be a sharp point? So we probably should say j prime double prime equals 0 or undefined. Now, if they would have said that j is a nice smooth curve and it's, there's, whatever, no sharp points or something like that, we probably should say j double prime is 0 or
Is that because it changes
No, it doesn't have anything to do with concavity, because this is J prime and J double prime. They're just derivatives, so we're just talking about the slope. J double prime is a slope of J prime. So right here, the slope either has to be 0 or it's undefined. Right? That's what you want to say to yourself. When you've got this problem and they tell you J prime and they ask about J prime, you got to think, what's J double prime? J double prime is the slope of J prime.
So if we
I was
set it,
thinking J.
Right, and that's, remember what I was saying earlier about on this next quiz, you gotta make sure what functions are you thinking about, right?
so if you said it could be a possible inflection point of J.
Are you talking about on B?
Alright, yeah.
Because A was just talking about J double prime, right? So B now says, what does this imply about J?
Possible inflection.
Possible or an inflection point? It is an inflection point, okay? Because J prime is going, not because of this, but because they told you it was a local max, right? Remember, we said only if J prime was a flat spot would that be a problem.
What about, it could be that.
But that's okay, because look, okay, let's go to the chart. Again, it all comes back to the chart, right? We have the J prime graph, it's a local max, right? So whether it's a V or a parabola, right? What's happening? J prime is increasing, then decreasing. So what's happening? J is concave up, then concave down. We're switching concavity. So it's got to be an inflection point. We're switching these two columns. J prime is going from positive to negative. In either one of these two cases, J prime is up, then down. So this is, for sure, an inflection point, or it has an inflection point at 2.
If we put that it changed from concave up to concave down, like on the quiz, would you?
So if it says, what does this imply about J, and you said at that point it switched from concave up to concave down, that'd be okay. Because it doesn't say to name that it's an inflection point necessarily. It just says, what does it imply about J? And that's true. J is changing from concave up to concave down. That would be okay. All right. Now, I want to do 5, and then we'll probably jump to a different one here. So 5 says, suppose that f of negative 3 is negative 1. So f prime of negative 3 is 0. And f double prime of negative 3 is 2. Is it just 2?
Yeah.
2. Yeah. Okay. Is x equals negative 3 a local minimum of f? So what they've done, instead of giving you any graphs, they've just told you to cut some points. So which point do you focus on first? I would focus on this middle one, because that's the key one. Now, what does that tell you? The slope is 0, which means
Stationary.
it's got to be one of these 3. Right? They're asking if it's a what? Local min? Why is it, Jesse? That's the second derivative test that we just learned. If you have a stationary point, it's one of these 3, and they told you the second derivative is positive, right? The second derivative is positive means it's got to be concave up. The only one of these situations to be concave up would be this one right here. It's a local min. Yes, it is. What about f of this is negative 1? Doesn't mean anything. That just tells you where the f graph is. Just tells you where it would be, but that doesn't have anything to do with it. So that is a way they ask you. That's where you use that second derivative test. You really got to put this information together. That was tricky. All right, let's jump to another one that is one of your questions, and that is number 26. Okay, here's number 26 right here. Number 26, they're asking you. Let me make sure I put this on here. Okay, 26, they're telling you one of these is f, one of these is f prime, and one of these is f double prime. You tell me which one. So you guys go ahead and do that. Did you get something on your calculator screen?
Yeah.
Quick poll. Now what do? I don't remember what to do. Oh, yeah. So there you go. I want to see your answers here. So so I said BCA, right? So if you think, if B is the F graph, and C is the F prime graph, and A is the F double prime graph, in that order, put BCA. Right? Just type that in. And then I think if you go up to the little triangle up at the top, you can submit the poll then. So just put them in that order. Don't put commas or anything. Just do it the way I did it. Just do BCA, ACB, ABC, CBA, whatever. I don't think you have to submit necessarily. It's up in the, but I don't know if you do submit, then you might not be. Then it goes away because it just. And then if you submit, then it goes away. Yeah. I don't think you have to hit submit, but boy, you get your quick. One is F prime, one is F double prime. Huh? Yeah, you could resubmit. Oh, if you already did? Well, that's a good question. Maybe you can't. Why, you change your mind? Well, why'd you get in such a hurry? We've got quite a split. Who hasn't submitted yet? Tim, did you submit? Zach, you haven't? Okay. You got 30 seconds. All right. Well, we got quite the range of answers here. That's the first one of these we've done. I'll be honest. I struggled on this. I still remember the summer workshop I took where I first saw one of these problems, and I was like, "Oh wow, you really got to think about this." All right. Somebody feel confident in their answer and want to explain?
Well, I mean, I could explain my answer, I don't know if it's right.
Okay, go ahead.
I can say what
Which one do you think is F prime?
I thought F prime was A,
Okay.
because like, it's positive, and then it goes to negative, so then I thought that F could be B because it's increasing, and then it goes to decreasing, so then I thought that C could be F double prime because it's concave up, and then it's concave down.
Okay. I'll tell you.
C can't be A because C's negative.
I'll tell you what. Let's go through the first part of what she said. Yeah. Let's talk about the first part, and then we'll see if there's some holes in it. So if this is F prime, I focused right there, and you said this goes positive to negative, right? So then this graph goes up, then down, right? Okay, and then keeps going down all the time, right? While this is negative the whole time, this keeps going down, right? And then also we've talked about inflection point, how at the minimum here, that should be an inflection point right there, right? The minimum of F prime should be an inflection point right there, which it seems to be. So that looks pretty good. But what I think she's missing is, remember how we talked about how F prime and F double prime have the same relationship as F and F prime? So if these two have a nice F prime relationship, couldn't these also have a nice F double prime F prime relationship? Okay, so I like your thinking so far, but here is where I think Max is saying it can't work. Because if this then is F double prime, notice how this one is always below the x-axis? That means this one is always what? No, this one. When this is below the x-axis means it's negative, thank you, yes. Being below the x-axis means it's negative, right? So C, the F double prime is negative. Now what did we learn about F double prime being negative? F is, well, not F prime, yeah, that's the same relationship. I want to do the F double prime to F connection here. If F double prime is negative, F has to always be concave down. So if this one is negative the whole time, the one you said was F has to be concave down the whole time, but it switches to concave up right there. So this would have to go positive there. So that makes that no good. So what that tells us then, but since I like these connections, then how about we make this F prime and this F double prime, right? And I'll be honest, I think the trick to these problems is to go in and find your roots, because that's where you've got this local max. I think that's the first thing you look for. But now I think that would have to make this be C. Now let's look at that concavity. Let's look at that new relationship we learned about F double prime. F double prime is positive to here, which means F has to be what? Concave up, which it seems to be till about there. Then this goes negative and this goes concave down the rest of the time. And that seems to work. And we know these two fit with each other because we already did that before. So it looks to me like it's got to be C, B, A. And the winners, unless you're changing yours already. Somebody's changed theirs. Oh, Zach did change it. You did too change it, and you weren't on there, cheater. Okay, so so who had it? Jesse and Max? Yeah, okay. All right, so here's your homework. Your homework is on that packet, and then there's also a Desmos here. Let me, and you can do this now, or you can just write down the code. But this one is going to be, oh wait, that's the wrong code. Sorry. That's for the makeup. Okay. This one. Okay, there's your code, student.desmos.com. Now this is for second. This is matching double primes with the original F. So again, here's what I would suggest. You're going to have F graphs that are red, I think. The F double prime graphs are blue. And so if I give you this, if you have this and it's an F double prime, if you have this right here and it's an F double prime, what's important about that? Positive, excuse me. Negative, positive, negative, positive, right? If that's an F double prime graph, what's that tell you about F? Concave down, concave up, concave down, concave up, right? Because F double prime tells you about F. Concavity, right? So negative to positive of F double prime tells you concave down, concave up, concave down, concave up. So you'd be looking for an F graph that had those changes of concavity. That's your matching there. Okay? So that Desmos and those homework problems. Okay?
Are we doing day 3 and 1.7?
Yeah, so you're doing the day 3 and the 1.7. You got a long weekend, so there you go. Matter of fact, I might even email you some more stuff to do on Saturday just because you got time. Yeah. Ask her. So be checking your email on Saturday for new homework.